Hello, exceptional students of Mrs. Whitney's. Welcome to section 10.3. So this is talking about experimental probability. So the last section we talked about probability in general. And there's really two main kinds of probability. There's experimental probability and then there is theoretical probability. So experimental probability is the likelihood that something will happen based on actually doing it. It's not theoretical, it's just actually doing the experiment over and over again and try to figure out what the probability of those events happening. It's the same sort of ratio that we talked about in the previous section. It's the number of times the event occurs divided by the total number of trials. So let's just do an example. So finding experimental probability. The bar graph shows the results of rolling a number cube 50 times. What is the experimental probability that you'll roll an odd number? So we want to talk about what the probability of odd happening. So this is the number of times that it happened over the total number of trials. So we know that we rolled it 50 times. It said it right here, that we rolled the number cube 50 times. So now we want to know what the probability of odd is. Well, if we roll the dice, and we got 10 times, it was number 1. Number 3, it was 8 times. And 5, it was 11 times. So we are adding together 10, 8, and 11. So 10 plus 8 plus 11 equals 21, 29. So the number of times the event actually happened. So that is the number of times the event happened. You guys are going to ask me 1,000 times what that really is because it's hard to read. The 50 is the number of total events. So 50 times we rolled the cube, we got odd 29 times. So if I take 29 and I divide it by 50, I will end up with 58 hundredths. And if I convert that to a percent, I would get 58%. That's kind of interesting. Is that what you expected? Because if I rolled it 50 times, and the number of times that I can roll odd are 1, 3, and 5, so 3 times. The number of times that I can roll it in even is 2, 4, and 6. So that's kind of a 50-50 shot. So that's interesting that we got 58 for an answer. Something to think about. All right, making a prediction. It rains 2 out of the last 12 days in March. If this trend continues, how many rainy days would you expect in April? All right, so we're going to talk about the probability of rain happening. So it rained 2 out of the last 12 days in March. So we know that that probability in March was 2 over 12. So this was the rain in March. There's 9 there. So rain in March, if I simplified that, I would get 1/6. So out of every 6 days, it rained 1 time. All right, so in order to make a prediction, we know that there are 30 days in April. So we are going to take 1/6 and we are going to multiply that by the 30 days, which means that I multiply those. 30 divided by 6 is 5. So it will rain perhaps, so 5 rainy days. In April. So that is our prediction. All right, let's move on to the next example. So now we're going to talk about theoretical probability. So we talked about there was experimental probability where we actually did the experiment. So now we're going to talk about theoretical probability. So that is when all outcomes are equally likely to occur, what would be the probability of it happening? Again, it's the number of favorable outcomes divided by the total number of possible outcomes. So you are going to randomly choose one of the letters shown in these little blocks right here. And what is the theoretical probability of choosing a vowel? Well, how many total blocks do I have? I have 1, 2, 3, 4, 5, 6, 7. I have 7 total blocks. How many of them are vowels? Well, 1, 2, 3. So there are 3 vowels. So the probability of choosing a vowel is equal to the number of times there is a vowel divided by the total number. And when I divide that, I get 43 hundredths, which is 43%. All right, using theoretical probability. So the theoretical probability of winning a bobblehead when spinning a prize wheel is 1/6. The wheel has 3 bobblehead sections. How many sections are on the wheel altogether? Well, if we know that it is the number of bobbleheads, say hello to Mr. Whitney. Mr. Whitney. He's coming through the door. Hello, Mr. Whitney. Say hello to my students.
Hi, students.
There we go. Okay. So it's the number of bobbleheads on the sections on the wheel divided by the total number of sections. So we're going to use a proportion to figure that out.
Do these students do that a lot?
Sections.
Trying exams?
Be
Unlike
nice.
my students?
Be nice, Mr. Whitney. Sections. There's a C in there. I'm sorry. Sections. There we go. Okay. So we know that the probability is 1/6. So we want to know that if it's 1/6, and we know that the wheel has 3 bobblehead sections, what is the total number of total sections? Well, if I multiply 1 by 3, I get 3. If I multiply 6 by 3, I would get x is equal to 18. So I know that my total number of sections would be 18. Okay, so comparing, one last example. So comparing experimental and theoretical probability. So again, like I was talking about showing the number cubes. That was kind of a weird example. Because probability-wise, it seems like we should actually roll 50-50. So let's talk about this. So rolling a number cube, and this time they rolled it 300 times. So it's a lot more than our 30 times before. So the graph shows rolling the number cube 300 times. So what's the experimental probability of rolling an odd number? So experimental means I actually did it, so I'm going to use the chart. So the P of odd number is equal to 300 because we rolled it 300 times. And odd numbers were rolled 46 plus 50 plus 5 because those are, or 49 because those are our 3 odd numbers. And if I add up all of those numbers together, I get 147. And if I divide that, I would get 49 hundredths. And if I converted that to a percentage, that would be 49%. So how does the experimental probability compare to the theoretical probability of rolling an odd number? Well, again, we know that so if we go back to 10.2, anyway, we know that we can figure out the probability of this. There are 6 different outcomes and 3 are odd. So that would be 50% because it's 1/2. So we know the theoretical probability is 50%, yet the experimental probability was 49%. So compare the probability in part A to the experimental probability in example 1. So as the number of trials increased from 50 to 300, the experimental probability decreased from 58 to 49. So it became closer. And what that kind of tells us is that the number of times that you repeat an experiment, the closer you're going to get to theoretical probability, unless there's some reason that you're not getting, like for instance, if one side of that dice was weighted, it might throw off. But if there's an equal likelihood that it would happen, the more you throw that die, the more likely you're going to get to theoretical probability. Thanks for watching.